Today I am talking about an eye defect called hypermetropia. In previous class I told you about myopia, now hypermetropia, which is also called long-sightedness. Look at the name, long-sightedness. What it means? This is an eye defect in which only distant objects can be seen clearly, but near objects cannot be seen clearly. This is the definition of hypermetropia. We can show this with the diagram like this. Let's say this is human eye, and in this defect we have to make the convex lens of eye thinner than the normal. And then in this defect, distant objects can be seen clearly. This is not the problem. But near objects cannot be seen clearly. The light ray coming from near object are diverging ray, and it won't focus on the retina. That's why it cannot be seen clearly near object. And where it focuses behind the retina, this way. Now what is the reason? Reason is very simple. Convex lens of eye is thinner than the necessary thickness, and that's why it is focused behind the retina. This diagram represents hypermetropia. If we have to write somewhere or say somewhere the characteristic of hypermetropia, then we can write this characteristic. Number one, this is a defect in which distant objects can be seen clearly. Distant objects can be seen clearly. I am writing shortly. But near objects cannot be seen. Objects cannot be seen clearly. This is one of the prime point. Now, distant object can be seen clearly, near object cannot be seen clearly means then where the image of near object forms. The second point we can see that near objects in this defect, near objects are focused behind the retina. Why near objects are focused behind the retina? Because in this defect, convex lens of eye become thinner and focal length becomes short. Focal length is denoted by small f, becomes short, and that's why it cannot focus the object on the retina, and its converging capacity is less because its power is also less. We can say powerless. That's why it cannot focus in the correct position, and that's why image forms behind the retina. This is another characteristic. Now next is this defect is because of one matter. In this defect actually the eyeball is bulged. This can be represented this way just for understanding. Eyeball is not normal like this. It is a little bulged up and down, gone up and gone down a little more than the normal size. This is bulged eyeball, and because of the bulged eyeball, this convex lens is also thin. That's why the distance between lens and retina increases, and because of this reason also this defect can be seen in human eye. That's why we can say this point also. In this defect, eyeball is bulged, which decreases the distance between lens and retina. That's why distance is decreased. That's why image falls behind. This way also it is explained. These are the characteristics. Now question comes, how do we remove this defect? The remedy of this defect. This defect can be removed by using convex lens. Now how we can show with diagram also. Look at this is the eyeball and this is convex lens of eye, which is thinner than the normal. And if we use convex lens in the spectacle, then what happens? The light ray coming from near object is first conversed by the convex lens of a spectacle. This way, instead of going straight, it is conversed, and these light rays are again conversed by this convex lens of eye. Again it is conversed by the convex lens of eye, and so by using suitable power of convex lens, the image falls on retina. Now we have to understand this way. In this defect, the convex lens of eye converges the rays of light, or convex lens of eye focuses the object behind the retina. But when a convex lens is used in a spectacle, then not only the convex lens of eye, but the convex lens used in the spectacle also converges the ray of light. And that's why twice the rays of light are converged. So converging point move in front of the previous converging point, and that's why the image falls on retina. This way we can correct this hypermetropia. This is defect, this is correction. These are the characteristics. Okay, this much for today.